Okay, welcome to our second session, Surface Decision Support Capabilities, ATD-2. So this breakout session is focused on overview of ATD-2 surface metering capability. As you mentioned in the previous session, ATD-2 is developed in response to a NAAC recommendation on departure metering based on TFDM concept of operation, and that is based on surface CDM concept of operation. In particular, ATD-2 is, as you know, a precursor of TFDM, early implementation of TFDM FAA program, which is currently under development with a target implementation scheduled in spring 2021 in Charlotte as a first site for full implementation of TFDM. ATD-2 has implemented a service scheduling and metering solution compatible with TFDM concept, and ATD-2 has been evolved in coordination with FAA TFDM program office, surface CDM team, and both commercial carriers and general aviation partners during all stages of development and testing in the field in Charlotte for phase 1 and phase 2. And following ATD-2 crawl, walk, and run approach, we started off tactical surface metering, which prediction of demand capacity of surface traffic in a relatively short time is made, and gateholder advisories are generated by the scheduler. And field evaluation of tactical surface metering began in November 2017 in Charlotte Airport during Bank 2. And in February 2018, the metering has been extended to Bank 3. In October 2018, which phase 2 began, we deployed a strategic surface metering capability that has a longer prediction horizon for demand capacity imbalance prediction aligned with TFDM concept operations, and proposes surface metering program to the users. You'll hear more about detailed tactical and strategic surface metering and evolution from Isaac just in a moment. In this session, you'll hear from the speakers, Isaac and Liang, how the metering has been evolved from tactical to strategic, and valuable lessons learned from the field evaluation that has been conducted for almost 2 years now. So American Airlines Ram Tower in Charlotte Airport, they are using our tool ATD-2 almost 24/7, and throughout the day there are 9 banks altogether. So they are using surface metering all the time, all depending on the demand and capacity. Some banks not as much as the other banks in surface metering usage. So we'll make sure, and then so this is a 1-hour session, so we'll make sure that we have some time toward the end for question and answers. So feel free to submit your questions through this conference IO website. So with that, I'll hand over to Isaac for presentation.
Thank you, Yoon. So as Yoon said, we're going to start with a kind of an overview of what surface metering is, how we evolved surface metering at Charlotte. Start with a recap of tactical surface metering, and then move on to how we're doing strategic surface metering, which is similar to TFDM at Charlotte. Talk a little bit about flight prioritization, leveraging surface metering, which is kind of moving beyond the basic benefits of surface metering, and then move on to some future plans and some lessons learned. So to start off with the overview, so I think everybody in the room is probably familiar with TFDM and the naming conventions and things like that, but just for anybody that's not, the goal of metering is distinct from scheduling. Is metering is trying to take some of the time that you would spend in the queue and pass that back to the gate. So you're still taking off at relatively the same time, but you're holding at the gate instead of in the AMA. And to do that, we assign a target off block time, a TOBT, to a flight, and a target movement area entry time. Those are the times that the flight should push back from the gate and get to the spot so that your sitting at the gate instead of sitting in the queue. And that happens during a surface metering program in SMP. That's a new TMI that's being introduced as part of TFDM, and we're trying it out at Charlotte. And so we're trying to hit a target excess taxi time. So the target, we define excess taxi time as any taxi time predicted to be beyond unimpeded. So that's just kind of defining some terms for anybody in the room that's not familiar with TOBT, TMAT, SMP. And so how did we get to where we are today? So we started off at Charlotte with, in phase one, with just scheduling. We said, can we predict takeoff times? That's the TTOT, the target takeoff time. Can we predict when a flight is going to take off? You know, if we can't do that, then how can we meter? So we started with that, got that working well, started scheduling flights into the overhead stream. That was kind of the crawl phase. Walk was, all right, now that we can predict demand capacity imbalances, we can predict how long flights are going to be in queue, let's start tactically metering flights. And that was, okay, we see metering is needed now, let's turn on metering, start assigning times. And then now we're into the strategic metering phase, which is where we wanted to end up and is close to TFDM, which is where we're predicting when metering is going to be needed in advance, going ahead and assigning those times, the TOBT and TMAT in advance so the airlines know about them in advance. Freezing them so there's confidence, and then also freezing the start time. And we'll talk more about kind of what that means as we go forward. So phase one, we started with tactical surface metering back in, as you mentioned, in December of 2017. November. Yeah, end of November, 2017. So the way we started with tactical metering at Charlotte was basically the scheduler that runs both the scheduling and the metering, the component of ATD-2, every 10 seconds says, do we need metering now? Do we need metering now? Do we need metering now? Oh, we need metering now. Let's turn on metering. Let's go ahead and show those times to the ramp controllers and tell them how long they should hold at the gate. I'll talk a little bit about the lessons learned, but we ended up with a trigger for turning on metering of looking at flights that are off the gate. Are they predicted to have an excess taxi time greater than a set target? And are flights at the gate predicted to have an excess taxi time greater than a set upper threshold? And then once we turn on metering, we are tactically updating those TOBTs and TMATs every time we get a new schedule. So they're kind of fluid. It's a tactical environment. But we would freeze them and say, this is your time when the pilot called ready for pushback. And the ramp controller put the flight on hold. So at that point, the gate hold had been communicated to the pilot, and the pilot had communicated it to the pushback crew. You know, expect pushback in 5 minutes. So we didn't want to change the time after that point in time. So that there didn't need to be re-coordination between all the different stakeholders. But besides that, we were updating the times pretty tactically. And then we would check at repeated intervals, do we need to turn metering off now? Do we need to turn metering off now? And so we would turn it off once all flights were predicted to be below a lower threshold. And so that's how we did tactical metering. And we were encouraged. We saw a lot of benefits. We learned some lessons from that. We started off, one of the big lessons we learned initially was we were looking at flights that were just at the gate, and we were seeing that we were actually starting metering too early. That was one of the biggest pieces of feedback we got after we started metering with the stakeholders there at Charlotte. We'd hold these retrospectives after metering and say, how did the metering go? And they would say, well, we felt like it was a slow start to the week. What we found was that we were starting metering based on flights that maybe were 10 minutes away, and so you had flights that were holding that were only being held just because metering was on. And we were saying, no gate hold, push back at your earliest off-block time, but maybe the pilot called in 5 minutes prior to the earliest off-block time. So we added an additional trigger to wait till there were flights in the movement area. And we'll talk a little bit about how we're kind of taking a step back from this in the strategic realm so that there can be some more certainty about when metering will actually start. An additional lesson we learned was with targets and thresholds. Initially, we started with a single target and threshold for both runways, but we quickly realized we needed to be able to tune them per runway at Charlotte because we have a mixed-use runway and a solo departure runway, so they have very different departure rates. So we ended up with a slightly higher target for the east runway at Charlotte, which has a mixed-use operation, and found that worked better just because it kept a little bit more demand out there, whereas at the center runway, it's about 1 flight per minute, and so we could go with a little bit shorter excess taxi time, but that would still keep enough demand out there. So we ran with surface metering like that for a good while, learned some lessons about how to display the times to controllers, what the procedures were for managing pushbacks, and how to just coordinate with the pilots. Once we had that down and we were moving into phase 2 at Charlotte, we shifted to a more strategic phase where we wanted to start getting information out to the pilots and the airlines earlier. So when we started with phase 2, we wanted to have a couple goals. We wanted to obviously build upon what we learned in phase 1, but we also wanted to prepare the way for TFDM because Charlotte is the key site for TFDM, and we wanted to make sure that Charlotte was prepared for metering. And so we wanted to start aligning more closely with what the strategic metering is going to look like as part of TFDM. And the goals there is to provide benefit to the users so that they can plan for when is metering going to happen, what are our gate holds going to be, get those times out there with more advanced notice. But we still want to make sure we're using the latest EOBT data, readiness information, and we built upon the existing tactical tools that we already had, just so that we would make sure we're building on a strong foundation of what we already knew. So we're kind of that crawl, walk, run. We were at the walk stage, and we wanted to move to the run stage. So we built upon what we already had. So over the next few slides, I'm going to kind of, is there a question? You want to repeat that?
Yeah, for Bank 2, which is the busiest bank of a day, there are like 75 departures and so how many the data samples? I mean, are we're dealing with surface metering. So I'm just telling there are about 70 departures and 70 arrivals. Slightly, few flights, less arrivals than departures for Bank 2. So it's about a little more than an hour period of time. All different directions.
Yeah. There is, some banks have a little bit more northeast flow, some are a little bit more going to the west coast, but it just varies per bank. That's actually a good point. I meant to speak about how we started with metering. We started just trying it out in one bank. We said, Charlotte is a very banked operation. There's very clearly defined banks. And so when we first went to Charlotte, we met with American as the lead carrier and said, when will be good times to meter? And we ended up settling on Bank 2 because it was early enough in the day that there wasn't a lot of disruptions, high quality EOBTs at that point, and there weren't just a lot of TMIs because there's not much thunderstorm activity that early in the morning. But it was a good chance to just try it out. It was a high demand bank, and so we were able to trigger metering pretty much every day. And that was a good first step. We said, okay, we're just going to do Bank 2 for the day. And then they liked it during Bank 2, and they said, okay, can we expand to Bank 3? And so we expanded to Bank 3. And then since then, it's been, can we keep metering later and later in the day, which has been very encouraging that coming from the users there at Charlotte, it's been, let's get some more benefit out of this. Let's move into later banks. Mike?
Out of the Bank 2, how many actual flights are there?
Yeah, so we have data actually from November 2017 up until like end of July this year. So like 23% of departures were advised for gate hold, and actually the percentage of aircraft held at the gate was like 16%, and then average gate hold time was about 6 minutes. Yeah.
Yeah, and I should at this point people to a later session where there's going to be a lot of stats on the benefits and how many flights are being held during this. This is so that session is benefits of surface departure metering while doing no harm to other operational metrics. That is the last session today in the Park West room. So I'd encourage people that are interested in that information. Yeah, and so to Mike's point, there's a lot of flights in that bank. But we're still seeing a lot of benefits from metering a quarter of the flights, and the gate holds often aren't even that big. They're in the 5 to 10 minute range, so it's short enough that we are looking at gate conflicts and things like that, and we're working with the airlines to mitigate those. But we're not causing significant gate conflicts, but we're still seeing benefits. So for phase 2. We wanted to kind of build upon that and keep going. And so we built upon the previous scheduler. And now I'll walk through kind of a day in the life of metering at Charlotte with strategic metering. So we're predicting when metering is going to be needed in advance. And this is the surface metering display that they use to manage metering programs and set targets and see what the demand looks like in the future. So you can see on this, there's kind of a table at the top that shows what S&Ps are in place, and then we show a prediction of what the excess taxi time is. In TFDM, this will be prediction of what the queue is going to look like. So this black line here is current time. Everything to the left over here is actual flights, so that's the actual excess taxi times that those flights experienced, similar to what you would see with an actual queue length. And then over here on the right is predictions of what the predicted excess taxi times are going to be. Each dot represents one flight. Where it is on the x-axis is when we predict the flight's going to take off. And then the y-axis, how high it is how much excess taxi time we predict the flight's going to take. And then we have the target, which is at 12. And so you can say, like, this flight right there is predicted to have 12 minutes of excess taxi time. And so our goal is to basically take the top of this and pass that back to the gate. And so this blue highlighted area is the period of when we say metering is going to be needed. And so when we turn on strategic metering, we're giving the controllers an idea of, okay, metering is going to be starting at, in this case, 2124 Zulu. And an average hold of only 2 minutes. It says 2.6 minutes is the average predicted hold, and a max of 7 minutes. So at the beginning of the day, we started actually with the metering capability completely disabled. Prior to Bank 2, we asked that the TMC in the tower turn on the time-based metering capability in the surface metering display. That was the display I just showed you. The TMC and the ramp manager collaborate. At this point, the collaboration is pretty much, they've agreed upon a set of numbers. It's not like they're having to call each other each morning. There's basically some set of defaults for the airport configuration. And we started off with the same values that we used we arrived at during the tactical surface metering. We've pretty much stuck with those with some variations. As we went along, we also added strategic parameters for phase 2. We added a lead time, which is how far in advance do you want to be notified about a predicted S&P. So right now we have it set at 60 minutes, which is at Charlotte about enough time that one bank is ended and we're starting to predict for the next bank. That's configurable as to how far in advance do you actually want to know about a metering program that's going to be needed for the next bank. And then we also have an additional metering parameter called the static time horizon, and I'll go into more detail about that one because that's kind of a key component of the strategic, is trying to lock in those TOBTs and TMATs in advance so that the airlines have some certainty about how much hold their flights are going to get. So this is the display that they use. It's another screen on that surface metering display. So you can see they turn on time-based metering in the morning. They can set the lead time and the static time horizon dynamically. Right now it's showing 0. That's where we started with in a kind of, once again, a crawl, walk, run. We started with 0. We've now inched it up, and we're currently at 15 minutes. And we're continuing to try and stretch that out a little bit farther. And you can see here are the targets per runway. So the east runway, we have 12 as the target, and the center runway, we have 10 as the target. So after they've set that, the system runs, and it will propose or recommend a surface metering program. And they'll be notified about that through this little symbol up here in the toolbar and the proposed notification in the notification panel. I'll talk a little bit more about, but I'll talk about it now. So we started and we were requiring the TMC to affirm all SMPs. So they can affirm an SMP or reject an SMP based on looking at it. We found that there wasn't always a TMC in the tower, or they were busy, and so the TMU would often have to go over there and walk. We had some issues early on where we were proposing an SMP and then turning it off, turning it on, turning it off, and they found some frustration with that. So we ended up adding an auto-affirm capability. So if the auto-affirm capability is on, then the SMP will be immediately affirmed. Similar to in TFDM, there's an auto-affirm for SMP recommendations for compressions and reassignments. So we apply that to the SMP as well. So once an SMP is affirmed, once SMP is recommended, this bar will show up in the surface metering display where we'll already talked through. We show the status of it, which runway it's for, start, end time, and the different statistics about how many flights are going to be affected. So just to kind of walk through the progression of an SMP, it starts out as a proposed state, and then that's saying we need metering. We think the system says, hey, we're proposing you meter during this next bank. Affirm means, yes, we are planning on metering. This metering program is still needed, and somebody either clicked it or there's auto-affirmed enabled. The user could say, hey, weather's kind of crazy right now. We're not sure what's going on. Maybe metering is not the best during this next bank. And so they can actually go in and say, nope, we're not going to do it this bank. So they can reject that metering recommendation. If an SMP is affirmed, once the start time is reached and the triggers are reached, the SMP will go active. At that point, we start showing the times on RTC. When the SMP is in a firm state, we actually do assign TUBs and TMATs to the flight so the airline can see them in advance. But for the ramp controllers that are actually using the tool, we don't show them until the SMP goes active, because that's when they actually need to know about them. But for the other more planning roles, we do assign TUBTs and TMATs in advance. Once the SMP ends, it goes completed, and then there's another obsolete state, which is saying, this SMP was at one point proposed or affirmed or rejected, but we don't really need it anymore, so we're going to put it into an obsolete state. So quick overview of how our scheduler does metering. This is a little bit more on the technical side, but we start off with a first pass of the metering schedule, and we say, let's do first come, first serve when there's not a need for metering, and then we do first scheduled, first served when we think when the excess taxi times get above a target. First scheduled, first serve is on our way to RBS, so TFDM will be doing full RBS, which is ration by schedule for those in the CDM community that are familiar with TFM. That was what was agreed upon for how to assign times as part of a metering program. Basically allows an airline to get credit for any flights that they cancel, so that they're encouraged to cancel or delay flights early because other flights that they have will be moved earlier. We're doing first scheduled, first served as kind of approaching that type of capability. Once we had that first pass, then we predict when an SMP will be needed, and we have the capability of switching back to tactical mode, but we have not switched back to tactical mode since we went live. We update SMPs based on user actions such as affirmations or rejections. And then if metering is needed, then we assign the TOBTs and TMATs, and we take into account prioritization. I'll talk a little bit more about prioritization coming up. But this is a way for the airlines to say, we want to do some swaps internally and reduce the gate holds on our flights. And then we do a final pass once we have all the TMATs assign and say, okay, given that we predict flights are going to push back at their TMATs, this is the order we expect them to get to the runway. And that's what we show in the timeline for the different flights. So speaking of flight prioritization, nope, go ahead. So in those prediction passes, the dark blue ones, we predict the flights. So once it has a control time, we predict the flight to take off. In the first pass, we predict the flight to take off at the control time or a little bit before, and we do have in a CTD buffer trying to get the flight out there early. In the second pass, we do a little bit more of an EFTT thing, earliest feasible takeoff time, where we're trying to give the controllers an idea, hey, this flight might get to the runway earlier, and this is the time that you would want to request if you're going to renegotiate this release time. But for the assignment of TOBTs and TMATs, we're saying, what is the pushback time that when should you push back to get to the runway a little bit in advance of this release time? Yeah. So one of the things we heard from the airline was, hey, we need a way to prioritize flights and say, this flight needs to get off the gate early. So the ramp manager has the ability in our ramp tool to mark a flight as a priority. This serves kind of two purposes. I'll talk about the substitution in a second, but it also just serves as situational awareness for the ramp controllers. Hey, this is a priority flight. Let's get this flight, out, and ahead of other flights if able. But in terms of the metering, what this does is, in the back end, Leong and others have worked a lot on this, is to basically do a shuffle substitution. So if it's way up here late, it's going to try and move it earlier by swapping it with other flights from the same airline. So if it's American marking a flight as a priority, it's not going to do a swap with a Delta flight or a Southwest flight, so it's only affecting American flights. This is a tool capability that we gave American, but in TFDM, there's similar type of capability, but it's a substitution. So as airlines and vendors, be thinking about how to translate a priority into a substitution type capability so that you can submit it as a substitution to TFDM. And there's a later session on substituting flights in TFDM with SWIM tomorrow afternoon. And for those that want to understand more how substitutions work in TFDM, I would encourage you to go to that session. In terms of how to prioritize flights in TFDM, you can say, let's just swap these 2 flights. Let's do 3 flights, swapping them down. Or you could build a tool that says, we're going to mark this flight as a priority, let the algorithms figure it out, and submit that to TFDM as a substitution. But the airlines have found this useful for, let's say there's a arrival coming in and it has a gate conflict, and we're saying, hold that flight on the gate for 10 minutes. They say, we can't hold that flight on the gate for 10 minutes. They have a couple of options. They can prioritize the flight and get a reduced gate hold, or they can push the flight back and hold it in the ramp somewhere, but at Charlotte, the ramp space is confined, but that's always an option to push back, hold in the ramp, and then get to the spot at the TMAT. And in TFDM, you can even hold in the movement area up until your TMAT. So part of the goal of strategic metering is to allow their airlines to leverage surface metering. This was a phrase coined by Mike Bryant, former HEC coordinator at American at Charlotte. He wanted to, ramp director at Charlotte. He wanted to be able to pass benefits back to the customer, which is a goal of TFDM, is, how can we benefit the customer with surface metering? When you're holding the flight at the gate, can we get that information out to our gate agents and other people earlier so that we can pass those benefits back to the customer by, helping people make flights or making sure people need to get to go where they're going. So we wanted to be able to tell the airline with certainty, hey, how much gate hold are you going to have? Because in phase 1, they had an idea in general, but the times could still fluctuate, but they wanted to have confidence. So the phase 1 tactical freeze was freeze when the pilot calls ready. But we wanted to move to a more strategic freeze where we could say, all right, a certain amount of time in advance, we're going to lock in your TOBT and TMAT. And so that's where we introduced what we call the static time horizon. So basically, how far in advance do you want to lock in that TUBT or TMAT? So the static time horizon is basically a sliding window. And, you know, we're saying any TUBT within the static time horizon is frozen. That was a little bit of a compromise between TFDM is freezing on the TMAT. Any TMAT that is within the static time horizon will be frozen in TFDM. We're doing TUBT because we were more focused on TUBT at Charlotte, but with TFDM, the focus is on the TMAT. And so right now we're working with Charlotte to prepare for TFDM, and we're kind of saying, hey, you know, we want to be stretching this time out farther, but there's also a little bit of a trade-off, and that's going to be up to each airport to kind of identify what that trade-off is. In TFDM, if you want to go tactical and set the static time horizon to 0, you could do that. Or if you want to be more strategic and set that static time horizon out longer, that's definitely an option too. So if you have a short static time horizon like we had in basically phase 1 with tactical metering, you're never going to freeze that TMAT until the flight's already in the movement area. What that does is allows you to kind of squeeze the most benefits out of the queue. You can say, we're going to, if the queue gets a little bit longer, we're going to go ahead and give you a new time. But when you start locking them in advance, it allows you to pass back benefits to the customers. And so we're right now working with American at Charlotte to stretch this out. So we started with a 5-minute static time horizon, then we upped it to a 10-minute, and now we're upping it to a 15-minute. And we've been evaluating how well are we managing the queue during this time frame. And we're starting to learn a lot of good lessons about what this looks like as we go forward. I think the kind of for all of TFDM and surface metering and ATD-2 to work, there needs to be kind of a lot of policies and procedures and just understanding how things work. So one thing we found out was when we started increasing the static time horizon, we noticed that a couple occasions, hey, the queue was running a little bit dry. We went back and looked at the data, and we said, oh, well, look, you're moving a bunch of flights to the center runway because of operational necessity. Hey, can we start getting those operational necessities a little bit earlier? Because that's, if you want to be more strategic, we need to, kind of plan in advance those what used to be tactical moves of runways a little bit more in advance. We're also building in some exceptions to the freeze. So, obviously, if an edict changes or release time changes, we need to update your TUBT and TMAT to match that time because we want you to be able to comply with that time. If an airline says, hey, we can no longer make this TUBT by telling us a new EUBT, so they say our earliest off-block time is now later than your target off-block time. We can't make that target. We'll go ahead and update the TUBT to match. And if that new time is still within the static time horizon, we'll refreeze. And if it's outside the static time horizon, we'll let it float around again. This is equivalent in TFDM to the reclamation window and protection period for those that are familiar with TFDM and surface CDM concepts. That determine those two parameters, and TFDM will determine how quickly we give out a new TUBT to match that EUBT. The other option that can change is we just recently put in a change where the ramp controller can prioritize flights that were within the static time horizon, and we'll go ahead and do swaps within the static time horizon. That's also allowed in TFDM. You can do a swap within the side static time horizon, as that's you as an airline making those changes. And finally, the last change that we're working on right now is basically adding in TFDM-like compressions. So I talked about, we saw the queue dropping, and we said, hey, we should be moving up flights to make sure that queue doesn't go dry. TFDM, there's that capability to compress within the static time horizon. We wanted to go ahead and add that capability as we're expanding the static time horizon out farther and farther. We wanted to add that capability in just to make sure we're doing no harm. So that's one area that we've been working on with Charlotte to move to a more strategic type environment and making sure we're aligning closer with TFDM. So the focus over the next year of operations at Charlotte, the last year of ATD-2 is going to be, let's work with our stakeholders there at Charlotte to align as closely as we can with TFDM. We're working with, I saw Bernie in here earlier, and others from Charlotte to figure out what do we need to do so that Charlotte is ready for TFDM, and go ahead and figure out a lot of these types of last-minute operational necessity runway changes before TFDM goes live? Can we work that out early? Another area that we've identified is freezing the S&P start time. So as I talked about, we had been tactically triggering metering. We said, let's wait until we have flights off the gate to trigger metering. The prediction is we're predicting when a flight will be off the gate that has above the target, but you know, we wanted to be able to say, hey, ramp managers, this is when metering will start. This is the start time of metering, and that will be similar to what TFDM is also doing, is saying this is when metering will start. You know, for them to be able to pick flights and say, hey, we're gonna, you know, maybe hold that flight on the gate a little bit longer, and you know, not hold the gate on the flight longer, but we're gonna go ahead and identify that as a flight, you know, has a 10-minute gate hold. Let's leverage surface metering with that flight. Let's pass back some benefits to the customers. They need to know in advance, prior to metering starting, that this is the set of affected flights. And so we're working right now with American to test freezing that start time of the S&P in advance. So we've added that capability in the most recent release, and we're going to be working with American to pick certain days to test that out. So we've been looking at the prediction accuracy of our runway, our S&P prediction accuracy. So you can see here on the top graph, this is some recent research we've been working on with American, is saying, okay, how many S&Ps do we know about how far in advance? So up here is 60 minutes in advance, and over here is right when the S&P starts. So how far in advance do we actually know about an S&P? So as you can see, you know, about 30 minutes in advance, we know of about 200 of the total 300 S&Ps that we've had so far at Charlotte. This is for runway 36 right. So we're seeing that, you know, we need to, we're trying to do a better job of predicting when an S&P will actually happen earlier in advance. You know, some of this is just the way the demand changes. Some of this is working with TMCs to try and set up the runway load balancing a little bit farther in advance. Do we need to do some adjustment to our rates at all? Those are the types of things we're working through right now to identify. And you can see with the tactical trigger to metering what our start time accuracy is down there at the bottom. So we're predicting, you know, 60 minutes in advance, 30 minutes in advance. This is what our start time is going to be, and then we tactically trigger. And so you can see kind of how accurate our predictions are. So we're within 5 to 10 minutes generally, which is pretty good, but we want to try and get better so that we're not holding flights at the gate that don't need to be held. So we're working with American on that. One thing we've noticed is that we're doing better on the east runway than we are on the center runway. So you can see that we're actually not predicting as many S&Ps as we would like in advance. A lot of them are with short lead time. So we're trying to identify what are some of the causes for that. And you can also see that we're generally predicting, so this is actual minus predicted. So basically this S&P started 5 minutes later than we were predicting. You can see that general slope. So we're seeing that part of it is the tactical runway changes that we were talking about, and we're working there at Charlotte to try and figure out how to make those a little bit more strategic. We're also, you know, looking at, you know, so what often happens is the metering holds are much shorter, and so they're just barely above the upper threshold. Can we figure out how to actually predict that S&P a little bit more accurately in advance? So this is kind of an area of research that we're going to be working on over the last year as we prepare for TFDM, and just making sure that, you know, we've kind of worked out some of these kinks as prior to TFDM being deployed to Charlotte. But you know, we're going to be trying this throughout the freezing the start time with American, and working with them to pick flights to leverage surface metering on, so that they can kind of provide benefits to their customers. So some lessons learned in future work. So we are seeing that the more accurate the EOBTs are, the better our predictions for the S&P start time is going to be. It's just another case where improved EOBT accuracy really helps. There's a session at the end of tomorrow on benefits of good EOBTs to surface metering, which has some interesting results on, if we have uncertainty about our EOBTs, then we have to pad our schedule a little bit more. We can't get as much benefit because we don't know exactly when flights are going to push back. We have to run with higher targets. So it's just an encouragement for anybody in an airline trying to figure out how to make a case to their management for why do we need good EOBTs. You can get more benefits out of metering with better EOBTs because you don't have to pad your schedules and your the targets as much. You can run with tighter targets. You can run with tighter CTD buffers where you're not trying to get flights out to the runway farther in advance because you have more certainty about when flights are going to push back. Auto-affirming SMPs was another thing that we got feedback very early on. Like I said, we got frustration from the TMCs just about being able to always click that button. And just the workload, sometimes they're busy, sometimes there's not a TMC staffed, and so that was one capability that we added in. So where are we going from here? We plan on working with American, as I said, to continue extending the static time horizon. We want to really work with them to leverage surface metering. As we go to those longer ones, we're adding in the SMP compressions, similar to TFDM's compressions, so that we can reduce the risk to running the runway dry. And we're going to be testing freezing the start time. So really our goal is to say, okay, great, we're holding flights on the gate, we're reducing fuel burn, we're seeing a lot of benefits there. Can we now start saying, maybe help a passenger that runs up to the gate, sees the plane out the window and says, that's my flight, why can't I get on that flight? Well, if surface metering is happening, maybe they can make that flight. So we're trying to figure out ways to work with American to make that possible, and hoping to see some good benefits from that as well. So at this point, want to open the floor up to some questions. Joe? Yeah. Yeah, so the question was, are we expanding out banks farther? So currently, the way we have it set up right now is we basically every day meter banks 2 and 3 if there's a need. And then for banks 4, 5, and 6, it's really up to the ramp manager and TMC to make a decision based on kind of what the weather's looking like, what they think, just how the day is going. So we do regularly meter into banks 4, 5, and 6 at Charlotte. Sometimes bank 7 even. Phil? Right. So, sorry, the question is, how, with weather, how do you cope with the weather? So that's where a lot of the traffic management initiative data exchange comes in. So the fact that we are getting the TMIs in the system and the system knows about those APREX release times, those edicts, and can schedule the flights on the timeline at those times and space other flights around them, gives us a picture of the demand. The fact that we're getting fixed closures and know which fixes are closed, which ones are getting rerouted over, that allows us to update our runway predictions so we know what the demand for a specific runway is going to be. So if it's just some edicts and APREX, many times they will meter because it's specific times. They can hold the flights on the gate for those times, or they can push them and let ATC if they don't have the gate space. When you start getting lots of swapping and long holds, it gets more difficult. But we're still seeing them meter later in the day. I don't know if anybody from Charlotte is here to be able to answer those questions, but yeah.
Okay. We also like to honor the questions submitted through this web. So we'll get to you later. So we have like 4 questions here. First question was the auto affirm an ops request or engineering need? I think we answered this question. It's more like an ops request, yeah. Right? Yeah.
Yeah. What we found was the ramp managers were also having to call up to the tower saying, "Hey, can you please affirm?" because it had been not noticed.
Okay, we have another question here. Are SMP lead times greater than an hour feasible?
I would say yes. I mean, so basically, we can predict an SMP as far as we have demand predictions. Is an SMP at the end of the day useful when you're at the start of the day? Maybe not. Maybe at some airports it is. That's why it's a configurable parameter.
Okay, I have a question for Liam. The next question is, are the number of gate conflicts a decision point in determining if metering can occur?
No, we don't consider gate conflict. No, gate conflict is not a decision whether metering can occur or not. We really turn on metering if the demand and the capacity balance is reached. So,
From the automation perspective, but there is a discussion happening a little bit with the ramp managers and TMCs on just how to manage those gate conflicts. Is talked about in the previous session we did the overview. We do have common situation awareness about which flights have gate conflicts between the ramp and the tower, which is a capability in TFDM where the airlines can send in this flight has a gate conflict, and TFDM will be predicting how many gate conflicts a SMP will cause. So that's an area where you might want to, the TMC and the ramp can negotiate over targets and things like that. We have seen cases where, they see a lot of gate conflicts and they'll raise the targets so that they're holding on the gates shorter to try and get the flights off the gate.
Yeah, I have a comment on that. This is a really excellent question because this is really opportunity for data science or data analytics in the future. So we have lots of data, historical data. So in certain situations, like arrival bank may happen earlier than usual, then those type of event, we may be able to say, oh yeah, in this case, metering may be postponed a little bit later or something like that. Can be advised to the manager. So this is something that we are very interested in future. Research maybe sometime later. Yeah. Okay, I have one more question here, and then go back to the audience. Did early arrival and reduced gate rest time become a factor in setting triggers?
So early arrivals are mostly affect the gate conflict. Because there's less certainty in the delays throughout the day, and when a flight is going to be able to get there, you often have larger block times, which means when the weather is nice, the folks at Charlotte will tell you sometimes it's the worst day because they have the arrivals all showing up 15 minutes early and causing gate conflicts. So, that was a consideration and kind of, as you talked about, how to set your targets and deal with the gate conflicts. I'm not sure what the gate rest time is. Turn times maybe, so the turn times do affect EOBTs, and if you have a tighter turn time, then any delay in the arrival is going to affect your EOBTs, and then the EOBTs drive the demand predictions.
Okay, let's go back to the audience. There was some, gentlemen, yeah, go ahead, please.
Yeah, so we're still working through it. I mean, so we've been meeting with American Airlines biweekly and saying, okay, we're going to start with a 5-minute. How does that work? 10-minute. And so to really be able to leverage surface metering and say, hey, maybe missed connection passenger, you can make your connection. You need to have at least a minimum amount of lead time. So Americans told us kind of what they want to get to, and but on the other hand, sometimes there's other trade-offs, like with the queue drying up and making sure we have enough demand out there. Other trade-offs that might not always be thought about is, what are you using as inputs into your EOBT predictions? How far in advance do you get those data elements for your EOBT models, which is really what gives you the high quality demand predictions? So if you're freezing before you even have any inputs into your EOBT model, then you're losing out on some accuracy there. So those are the types of trade-offs that we're working through right now with American at Charlotte.
From user feedback, so Isaac said we started off like 5 minutes static time horizon or 10 minutes and now 15 minutes. So this is purely based on user feedback. So they didn't see any noticeable significant differences as we increase the static time horizon. But I guess data analysis may be able to reveal some characteristics in the predictability and so on. Stability, so that's something that we may, want to look into future, study. And
Is there another question out here in the floor anywhere? Okay.
all right,
Oh.
Go ahead, please.
Yeah. So
Yeah, worst case.
So
Yeah.
what was a kind of a worst case scenario for metering? I would say probably cases where they're swapping fixes a lot because we don't have accurate prediction of which runways a flight's going to. So it's hard to know what the demand is going to be at each runway. You were bringing up miles and trail and how that would affect. So the case was where there's miles and trail in the overhead stream, or mm-hmm. Right. Yeah. So the question is, how does, when you have miles and trail and you have an omnidirection bank where you can put splitters in versus a bank where pretty much everybody's heading the same direction and you have miles and trail. So at Charlotte, we indicate which flights have a miles and trail, but we're actually not spacing them out in the schedule if we're metering due to the miles and trail because we wanted to avoid we didn't have a capability at the time to front load the queue for the miles and trail. So in TFDM, there's a idea of categorical metering where you meter to a miles and trail program. So you can manage how many flights you have out there for each miles and trail. So if you had an omnidirectional, you could manage that with a categorical, or you could manage it with, there's also a way to set what percentage of flights you want in the queue to each fix. It was another way to manage it. ATD-2, when we were starting off, we didn't have that capability. And we were concerned that if we didn't front load the miles and trail queue, we would end up missing a slot. We've heard that from a lot of the ops group, is that they want to be able to make sure there's enough demand out there so that every miles and trail opportunity is hit. And we wanted to just start off with let's make sure basic metering works. And so that's where we started. So you would see the queue grow a little bit. I think the TMCs would set the targets accordingly. And TFDM, you could change the rates a little bit to control that as well.
I have a question here. Okay, this may be a good question for Liang to answer. What is the predictive accuracy of the surface scheduler? We could have lower scheduler buffer and longer freeze horizon with better predictions.
Okay, so for I think the later sessions by Jeremy probably have data to show the accuracy, but for Charlotte, one of the hard part is the dual-use runway. And so we deployed a customized TBFM system to increase our arrival prediction, and that has been quite good, quite accurate. But UBT accuracy is the other factor, that if we have a pretty good arrival prediction, but we don't know how good that UBT can, that typically limit our accuracy. So I don't have a number, I guess I can't give you a number on how good, but what we've came up through experiment and also just the real life operation is for the dual-use runway, we like about 12 minutes of a queue, which is equivalent to about 6 aircraft if there's a full arrival bank coming. So we can depart one between each arrival, which is about a little more than 2 minutes. And then for the single-use runway, the pure departure, we like to about 10 minutes. That's about 10 aircraft. So those are the two numbers we, through the experiment and also through just real life, that's what we settled on. And that's as low probably as we can go to safely not run the queue dry.
I would say that the TTOTs have gotten, the predictions have gotten very accurate at Charlotte. I mean, you've tuned them very well.
So the rate, departure rate has been very good. Yeah. We can predict probably easily 15 to 20 minutes before, how to say, the TTOT, 15